Hello, my name is Tamar.
And my name is Patricia.
We are Industry Solutions intern here in Barcelona, and today we will be discussing how to enhance flight management with real-time data strategies. Flight management is the coordinated process where airlines, air traffic control, and the airports work together to ensure the safe, efficient, and timely operation of flights. However, there are several challenges associated with flight management when disruptions occur. Now let's discuss these challenges and the solutions. Delays caused due to disruptions are a major challenge for airlines. From sudden weather changes to crew unavailability, these issues lead to significant financial losses, approximately 4,300 euros per hour per flight. But the damage is not just financial. One delayed flight can cause a domino effect, leading to further delays and operational chaos. This domino effect is known as delay propagation. Without an effective system to manage it, delays continue to spread, costs rise, and customer satisfaction plummets.
Existing approaches to find a solution include airline planning and airline recovery. Airline planning focuses on optimization prior to the flight, while airline recovery targets a feasible solution that can be obtained in real time. While both these approaches are crucial for effective service, airlines often prioritize improving pre-flight planning, which can result in underdeveloped recovery systems. The consequences of this include delay propagation, financial and operational damage, and customer dissatisfaction. It is crucial to focus on effective airline recovery systems. For example, a real-time data platform. This is where a unified platform with real-time flight data becomes a game changer. By identifying delays and efficiently reallocating resources, airlines can minimize the damage caused by disruptions and enhance the customer experience. Building such a platform requires robust data management. The airline industry generates a vast amount of data, from plane sensors to fuel consumption and costs. This data must be processed and analyzed in real time, making a flexible and powerful database like MongoDB essential.
Let's take a look at the architecture that you can use to build a unified platform with real-time data for your airline. To begin with, we are using an event-driven architecture. This architectural approach uses events to trigger and communicate between services. It is ideal for the airline industry because it enables real-time responsive handling of dynamic events such as flight delays or schedule changes. This allows for quicker adjustments to flight schedules and resources, leading to more efficient operations and a smoother experience for passengers. The main components that we use to build an event-driven architecture are MongoDB, PubSub, Cloud Function, and Vertex AI. MongoDB efficiently manages diverse and large volumes of real-time data with flexible schema design and scalable storage. Vertex AI provides advanced machine learning for predictive insights. Cloud Functions automate event-driven processing, and PubSub ensures scalable asynchronous communication between services.
Among the mentioned components, it is essential to dive into how and why MongoDB features are beneficial for this event-driven architecture. To begin with, MongoDB's schemaless design allows for easy storage of varied event data without rigid schema constraints. This flexibility is crucial when handling real-time data, as its ingestion will be handled by events that drive the architecture's flow. Having constraints or blockers limiting these actions would imply having a less efficient and slower data processing. Additionally, the flexible schema MongoDB provides also allows our collections to adapt easily to the different events that may occur in our architecture, such as dynamic schema updates.
What is more, airlines need immediate data about delays to keep operations running smoothly. The features that help MongoDB deliver real-time insights include time series collections and aggregation pipelines. MongoDB's aggregation pipelines provide a powerful and flexible framework for processing and transforming data in stages, allowing for complex queries, calculations, and aggregations on time-stamped data. These capabilities are invaluable for airlines, enabling them to quickly analyze and respond to real-time events, ensuring efficient operations and minimizing disruptions. Now let's see how all of this works together. We have 4 collections. 2 for analytical insights, and 2 for operational insights. Flight costs and flight collections are responsible for analytical insights, while time series collection and flight plan simulation are responsible for operational data.
Combining all of the previously mentioned components, we have created a loosely coupled event-driven architecture. This combination offers a powerful solution for any modern application that requires scalability, flexibility, and real-time processing. Now, let's go briefly through the different microservices that form this architecture. Firstly, we have been talking a lot about data processing, but where do we get our data from? Simply enough, we have created a custom microservice for that matter, which allows us to control the data that we're receiving. Triggered by the user from the dashboard, this custom API is in charge of creating, processing, and publishing operational data simulating a flying plane, which will then be used in our platform. Once the operational data is published in our PubSub topics, is the time for our data transformation. Our application's static data is handled by a cloud function, which updates existing information in our MongoDB collection so the app has the most up-to-date information about the flight's path and disruption status. Then, it's time for a real-time data transformation. Whilst the previous microservice was only triggered when the path or disruption data were altered, these next microservices manage a real-time continuous data flow that gets the information from the topic, processes it, and then introduces it into our time series collection without noticeable latency.
Last but not least, we also have to target the creation of our analytical data. This is achieved by combining a cloud function that gets the data from our topic and a Vertex AI model that uses it to predict and compute specific costs. Then, this brand new analytical data is introduced in MongoDB so it can be easily accessed from our application.
Now let's take a look at the demo that implements this architecture. We have a main page powered by Atlas, Search, and Facets, where you can review, filter, and search the flights. Once you click the View Flight button, you are taken to the page where you can view the details of the flight. Here, you are presented with the flight overview dashboard and the real-time simulation of the flight. This showcases MongoDB's ability to effectively handle both analytical and operational data easily by integrating with services such as PubSub and Vertex AI. In the flight overview dashboard, you can see the initial path as well as new path after the disruption, along with the breakdown of delay and additional field costs incurred by the delay. Real-time data regarding delay occurrence and the corresponding costs gives Flight Operations Manager an opportunity to safely reallocate resources to minimize both operational and financial damage caused by this disruption. Reallocating resources can mean adjusting and deploying available personnel, equipment, and assets, such as rerouting planes, assigning backup crews, or redistributing ground services, to manage the disruption effectively and reduce delays and costs.
To sum up, integrating MongoDB into your airline's flight management system can save costs and dramatically improve customer experience. Want to see it in action? Check out our demo on GitHub. Thank you very much for watching.